Here's another equation that, if it's an equation of a circle, it's currently written in the general form. Not all equations that look like this are equations of circles. But if it is an equation of a circle in the general form, we can, through completing the square, we can rewrite it into the standard form. And when it's in standard form, we would be able to identify the center point and the radius of our circle. Let's go through that process again. First, we'll rewrite this equation so that we put the x terms together, the y terms together on the left side of the equation, and move the constant over to the right side. Now I will complete the square for each of these variables. I'm creating a perfect square trinomial. A perfect square trinomial is a trinomial whose factorization is the square of a single binomial. And the way we do that is by adding the right number to complete these trinomials, right constant. And the way we find that constant is we take half the coefficient of the first power term. Half of 6 is 3. We square that. 3 squared would be 9. That's what we will add in order to complete the square for the x variable, which we will have to add to the other side of the equation as well. Half of 10 is 5. 5 squared is 25. Adding 25 will complete the square for the y variable. 9 and 2 is 11. 11 and 25 is 36. So right now we know that our radius is 6. This becomes x minus 3. This becomes y minus 5 as the factorization for those trinomials. So the center point of our circle, x minus h, so the h value here is 3, plus the square of that, plus the square of y minus k, the k value is 5, equals r squared. Our radius is 6. The center point of our circle is the point 3, 5. The radius of our circle is 6. And we've been able to discern that information about our circle because we took the equation of the circle from general form to standard form through the process of completing the square.